need to discuss exceptions to the filling rules. And these exceptions apply to the electron configurations of a group or two groups of transition metals. We're going to look at copper first with 29 electrons, whose configuration we would, if we were following the rules we've discussed thus far, look like this. 4s2, 3d9. However, copper is one electron away from a full d subshell, and there is a special stability associated with having a full d subshell. So this is not the correct configuration for copper. The correct configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and when we get to the 4s, we only have one electron. One of these two electrons is promoted to the 3d subshell, so copper has a full d subshell. It gains that stability. The other two elements in the column with copper are gold and silver, and they also are exceptions to the filling rules. So they will promote one of the electrons in their S subshell in the highest energy level to the D subshell that follows. And you are responsible for these exceptions to the filling rules. Now there's another group of exceptions. So now we're going to look at chromium with 24 electrons, whose configuration we would, following the filling rules, be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. However, similar to the stability of a full D subshell, there's also stability, or that special stability, in a half-filled D subshell. So once again, this is incorrect. The correct configuration for chromium, 1s2, 2s2, 2p6, 3s2, 3p6, and when we get to that S subshell, we only have one electron, and we promoted one to the D subshell. So now we have a half-filled D subshell. The other elements in the same column of chromium that also are exceptions to this rule are molybdenum and tungsten. So you are responsible for knowing these are exceptions to the filling rules as well. Now we're going to move on to periodic trends.